everyone, this is Fabio Nascimento, and today I wanted to go over basics of EEG. We're going to cover definition, descriptive parameters, topography, and different montages. EEG stands for electroencephalography. So as the name implies, it picks up electrical cerebral activity. And the way it really works, as you can see on the screen, is we have a differential amplifier as a unity of an EEG. On the left-hand side of the screen, you can see those two white dots, and those are the inputs, and you have the differential amplifier in gray, and you have the output, which is the white dot on the right-hand side. As you can see on the left, input 1, or the one above, is picking up that activity at the top, and input 2 is picking up the activity at the bottom. Since it's a differential amplifier, it's going to put out in the output the difference between input 1 and input 2. So as you can see here at the top, the waves at the right-hand side are exactly the same. Therefore, if they're exactly the same in two different inputs, it's going to be canceled out. And that's why we don't see them on the right side of the diagram. However, the upgoing waveform at input 1 is not seen on input 2. So since it, again, captures the difference between the two inputs, it's going to be shown in the output waveform. We should all remember that on EEG, everything that goes up is negative, and everything that goes down is positive. And that's very random, but it's the convention we use. How do we describe what we see on EEG? There are 5 descriptors or parameters that we always use and we should all know about. The first one is frequency, location is the second, and then we have morphology, rhythmicity, and amplitude. Frequency is essentially counting how many cycles an activity has in a second. And as you guys know, that translates into the unity hertz. So what 4 hertz means is that there are 4 cycles within 1 second. You have to memorize these frequencies: delta, theta, alpha, and beta. To make it easy, delta is from 0 to 4 hertz, theta from 4 to 8 hertz, alpha from 8 to 13, and beta greater than 13 hertz. We're going to talk about location a little bit more on the next slide. In terms of morphology, it's basically how the waveform looks. And one important differentiation is between a blunt waveform, a sharp waveform, and a spike. And you can differentiate those based on the duration of the wave. If there's a wave whose duration is 20 to 70 microseconds, then it's a spike. If it's between 70 to 200 microseconds, it's a sharp wave. And if it's greater than 200, you can make a case that it could be sharply contoured or just a normal or blunt waveform. In terms of rhythmicity, we're not going to cover too much here, but those would be more in the realm of seizures, and there will be a rhythmic activity. But again, this is not the scope of this basic EEG talk. In terms of amplitude, it's essentially the height of the wave, and it's measured in microvolts. And it's easy when you're looking at the EEG to use either the scale, or you can use those fancy rulers where you can actually measure the amplitude of the wave. Location-wise, we need to understand a few things. Number 1, when you see an electrode that has an odd number with it, it means that it's located on the left side. And if you see an electrode that has an even number, it means it's located on the right side of the head. And if you see a Z standing for 0, it's standing at the midline. The letters help us identify where in the brain that electrode is placed. So F stands for frontal, therefore an F electrode will be in the frontal region of the head. So as an example, F7 will be an electrode on the left side of the head over the frontal region. T stands for temporal, FP frontopolar, C for central, P parietal, and O occipital. In the picture above, if we cut the head on the longitudinal axis, we have different chains. So up on the top, we have the temporal chain because it's covering the temporal lobe on that side. And then closer to midline, we have the parasagittal chain, and then the midline, and the same thing on the other side. On the graphic below, we're cutting the brain on a perpendicular axis. We see that in the anterior portion, closer to the nose, we have the frontopolar chain, and then the frontal after that, before the central chain, and then the parietal, and the very back, the occipital chain. So let's review these concepts. If it's on the left side, it has a odd number with it. If it's on the right side, it has an even number with it. And the letters represent where in the brain the electrodes should be placed. The difference between a channel and a chain is that a channel corresponds to 2 electrodes, whereas a chain corresponds to a group of electrodes. In this example, we can see, for example, here on the left side of the brain, we can point the left temporal chain. This will be a connection between FP1, F7, T3, T5, and O1. Let's talk about different montages now. There are a lot of them, but we should definitely know at least the big categories, which are bipolar and referential. On the left hand side of the brain here, we have the bipolar montage in yellow. And what it means is that we're going to compare the activity from 2 neighboring electrodes. So for example, here we're looking at a double banana, because if you look and if you have a bipolar on both sides, you can see that it seems like there's a banana on the left temporal and parasagittal chain on one side, and then the same thing on the other side. A referential montage, on the other hand, compares each and every electrode to a single electrode, or the average of all electrodes in the head. In this example, on the right-hand side and in red, we're comparing each electrode on that side to A2, which is the ipsilateral ear electrode. So the reference on that particular montage will be A2. Knowing what montage you're reading your EEG on is really important. And here we have the Christ Redeemer in Brazil. And if you've been there, you know that depending on where you're standing, you see a very different aspect of the same statue. So always remember to, 1, know which montage you're reading your EEG on and what the montage means. This is an example of a bipolar montage. It may seem a little difficult, but it's really not. So let's take a look at the left temporal chain. And we have that on the left-hand side of the head in yellow. And then we also have it on the right-hand side, just those selected electrodes. The way we look at that activity is comparing, as we mentioned, one electrode to the other. And that's the concept of a bipolar montage. So let's pretend we have a point of maximal negativity around the T3. In other words, the left temporal portion of that patient's head. So if we're comparing FP1 and F7, which is the first channel on the right-hand side, what do you think FP1 will show? Do you think FP1 will be more positive or more negative? You're correct. It's going to be more positive because it's farther from T3 or farther from the point of maximal negativity. So therefore, comparing FP1 and F7, the result, the output, will be positive. And as we learned, positive goes down on EEG. And that's why we have that down-going wave. Let's keep going. If we compare F7 and T3, F7 is going to be less negative or more positive than T3 because it's farther out from the point of maximal negativity. Therefore, the output in that channel will also be positive. And that's why that wave is also going down. Now, going to the third channel, T3, T5, if we compare T3 with T5, T3 is going to be more negative because they're sitting at the point of maximal negativity. Therefore, the output in that channel is going to go up because it's negative. The last channel will be T5 and O1. If we're comparing T5 to O1, T5 is going to be more negative because it's closer to T3, where the point of maximal negativity is at. Therefore, the output of the channel T5O1 is negative, and therefore it's going to go up. This is a very important point you all need to know and remember. Here, between F7T3 and T3T5, the waves are touching each other, or kissing each other. We have a name for that, and that's called phase reversal, and you might have heard it. And what it means is that on the common electrode to those two channels is where the point of maximal negativity is at. So in our example here, T3 is common to F7 and T3 and T3, T5. So at T3, the point of maximal negativity will lie. And we know that looking at the diagram on the left-hand side. So if you're reading an EEG on a bipolar montage and there's a wave that looks suspicious or epileptiform, you're going to look for a phase reversal, and that will show you where the point of maximal negativity is at. This is another example of a bipolar montage. But now, as you can see, the point of maximal negativity is in between two electrodes. So it's in between F7 and T3. And that's a little bit tricky, and we should know what it shows in the EEG. So let's do the same exercise. Let's compare FP1 and F7. FP1 is probably more positive than F7 because it's farther out from the point of maximal negativity. So therefore, the output in that channel is going to go down. Now, F7 compared to T3, the point of maximal negativity is in between those two electrodes. It's equidistant to each of them. So, as you can imagine, it's going to be isoelectric because if you compare one electrode that's looking at the same activity from the other, as we learned, as a differential amplifier, the difference is 0. So in that case, in that channel, it's going to be a flat line or isoelectric. So let's keep going. If we compare T3 to T5, T3 will be more negative. Therefore, the output in that channel will go up. If we compare T5 and O1, T5 will also be more negative, and that channel will also go up. Now, we can't really tell by looking at phase reversal where the point of maximal negativity is at. So this is a tricky scenario that we should know about. If we have an isoelectric, so in this scenario, the point of maximal negativity will be where there's isoelectric activity. A referential montage is a little bit different, but overall it's simpler. So in the referential montage, we're going to compare each and every electrode to a single electrode, or the summation of all activity picked up by all electrodes on the head, which is the average of the activity. So those are the most commonly used ones. So here in red, you can see that we're comparing each electrode to A2, which is the contralateral ear electrode. So now let's do the same exercise. If we compare FP1 to A2, and we have, again, the point of maximal negativity at T3, do you think that FP1 will be more negative or more positive? So more negative, because it's closer to T3 than A2 is to T3. So therefore, FP1 subtracted to A2, or FP1 minus A2 up on the top, will have a negative waveform. F7 compared to A2 is the same idea. F7 is more negative than A2 because it's closer to T3. Therefore, F7 minus A2 will also have a negative activity, therefore an upgoing wave. Same thing with T3, T5, O1. But now, if you look at the waveforms on the right-hand side, you'll see that the tallest wave is at T3A2. So that's different from bipolar, and that's a very good, important point that you need to remember. In a referential montage, you're gonna find out where the point of maximal negativity is at, looking at the height or amplitude of the wave. So in this case, we can see that the wave is the tallest at T3, A2. So that means the point of maximum negativity will be at T3. And we know by looking at the picture on the left-hand side that that's actually the case. So again, when you're in bipolar montage, what's going to help you identify the point of maximum negativity will be a phase reversal. Whereas when you're looking at an EEG on a referential montage, what's going to help you find a point of maximum negativity is the height of the wave. This is what I wanted to show you. So now, just for us to summarize and consolidate the key points in this talk. Number one, the definition of EEG. It picks up electrical activity from the brain, and the unity of the EEG is called a differential amplifier. So what it does, it differentiates from input 1 and input 2 and amplifies that signal in an output. There's a lot of parameters, descriptive parameters, that we can use to describe what we see. One of the important ones is frequency, and we need to memorize that the delta frequency is a range from 0 to 4 Hertz, theta from 4 to 8 Hertz, alpha from 8 to 12 Hertz, and beta greater than 13 Hertz. As far as topography, we learned that if the electrode has a naught number with it, it's going to be on the left part of the head. Whereas if there's an even number, it's going to be on the right side. And if there's a Z, which stands for 0, it's going to be at midline. We also covered the different montages. And the main ones, or the main categories, will be a bipolar or referential. In the bipolar, we'll be comparing two neighboring electrodes, whereas in the referential, we'll be comparing each and every electrode to a single electrode, or the average of all electrodes.